Well, hello, I'm Corrine Robinson, and I was fortunate to be the senior marker on questions 11, 12, 17 and 31 for advanced mathematics. I'd just really like to thank the markers who worked with me on that team. There was a lot of pressure this year, as I'm sure you would understand, with COVID and the delays and trying to get the marking done. So they did an excellent job keeping the pace and accuracy of marking. So first I'd like to talk about question 11. Question 11 was a common question with the standard course. And from what we saw from the advanced candidates, it was well attempted and most students had no trouble at all. Some of the errors that we did see was an incorrect multiplying of the 2 in the denominator, possibly to eliminate it. So commonly we saw x plus x minus 1 equals 18 as an attempt to eliminate that 2. Other inconsistencies in applying the algebraic techniques also crept in. So the learning outcomes then is that students really need to practice solving equations that involve 2 or more terms, either in the numerator or the denominator, just so that they're aware of the methods and the steps they'll take to solve those equations. All right, then question 12, also a common question with the standard course. Again, generally it was well attempted. And students used a variety of strategies actually to find x, y. That was perfectly fine. The sorts of errors that we saw was that students didn't apply the right angle trigonometry ratios correctly. For example, we might have cos 30 equals 16 over x, y, and then trying to solve that. The other error we saw was that students simply assumed that YZ was a radius along with the other 2. I think the thing for students to learn out of this one is to demonstrate all working. Don't just guess at things or pull numbers out of the air. They should practice identifying the correct trigonometric ratio for the triangle that they've got. And then they should practice solving equations involving trigonometric ratios. For part B, a little bit more complex. So the question certainly differentiated the cohort effectively. Some students efficiently found the shaded area simply stating the area of the semicircle, subtracting the area of the triangle. But we saw a lot of different methods used to find the shaded region. We did see a couple of people doing segments, correctly using the segment rules, but errors really did occur where people were trying to just find the shaded region without the triangle. So students often misinterpreted these shapes as semicircles themselves, with XY, say, being a diameter of that semicircle. Where students didn't just simply use the values that they'd already found in part A, but started looking for other values that would help them, they often introduced extra calculations in which they could make some errors. So an example of something students did was they realized that that was a radius, but then they decided that that could be the height of their triangle X, Z, Y. So learning outcome from this one, show all working. If you're finding new sides, demonstrate how these sides were found. It's certainly fine to use sides that you found in the previous part. Practice is needed identifying the correct formula and the correct dimensions for substitution. So students didn't necessarily use the area of a triangle. We saw areas of trapeziums, areas of kites, areas of sectors. So a variety of areas that are just not the shapes that they were looking at. So they really need to identify the correct formula. And then the next thing I think is identifying what dimensions would go into that formula. So if I'm using a half AB sine C, then I need to be using the two sides, either side of the angle, not something else. And then I'd say the other thing was the confusion around what these circular shapes are. They're segments, but students were not sure whether they were finding segments, sectors, or semicircles. So identifying the shapes correctly so that they can identify the formula correctly, and knowing what dimensions go into those formulas is really important. Question 17 was statistics, and again, a common question with standard. So this one, part AI, was generally well done. Students were able to substitute the correct information and therefore predict the average temperature. There weren't a lot of errors for this one, but where they were, they either didn't know what equation to use or they substituted the wrong value into the equation. Then interpreting the gradient in part 2. This was well attempted, but I think we need to strengthen the sort of responses students give when they have to write in sentences. So some of the common errors we saw was that they interpreted the negative gradient to mean that both temperature and height above sea level is decreasing. And then the other thing we saw a bit of was students discussing correlation instead of gradient, or perhaps as well as gradient. So perhaps they felt that what they put for 1 mark wasn't enough, and so they were looking for something else to say, and the obvious thing they talked about there was correlation. So this question's about gradient. They need to focus in on gradient. So I suppose the learning outcome then is to practice making succinct sentences that are precise and accurate about what we're talking about. And you can use values as well as words to describe what the gradient means. So an example I have might be that the average daily temperature decreases by 0.011 degree for every metre increase in height above sea level. And you'll see I've colour coded it here. So the yellow demonstrates where we've applied it to the context of the question given, just taking the words or titles from those axes. And the green highlights where we're using words to describe or interpret. There's a decrease or an increase. And then the blue shows how the values of that gradient have then been utilised within the sentence. So I think the key for this one is perhaps not saying more, but saying more specifically about gradient. Stick to gradient and be quite specific. For part B, students had a variety of methods that they used to justify their choices. So some described the points themselves on the graph, or talked generally about the correlation, and some utilised the R value using those words. So the better responses were responses that were able to compare the strength of the correlation between the two data sets. And so the errors that we saw, or I don't know that you call them errors, but the things that didn't really fit what we were looking for, students used non-mathematical reasons to justify their decisions. So things like, sometimes they were accurate things, sometimes they weren't. Things like sea levels not consistent. So I think they must have been thinking, you know, there's rising and lowering tides, and so the sea level's not a consistent spot to measure from. And again, in this question, there was some confusion between gradient and correlation. Were they talking about the gradient, or were they talking about the correlation? That really needed to be clear, because the gradient won't be a reason to choose one or the other. So I think the learning outcomes for question 17, for me personally, there were quite a lot. It's a new aspect of the course and a new way for us to assess students. So I think students need to be clearly able to distinguish between correlation and gradient. And so that certainly needs more work from my impression of the marking. Students need to be supported to be clear when they're talking about correlation and gradient, and what effect each of these has. Students need some support with the vocabulary needed to describe these distinctly different elements and effects. So things like we use stronger and weaker for correlation, whereas greater or smaller can be misinterpreted. So they need to have the right kind of vocabulary there. When describing why something is better, students need to actually make a comparative statement. They need to somehow compare it to the other thing. So one way, not the only way, but one way they might do that is to state values for each and interpret them. An example I've got here is that latitude has a correlation coefficient of minus 0.897 and height above sea level has a correlation coefficient of minus 0.494. Therefore, latitude has a stronger correlation than height above sea level and would be a better variable to use to predict average maximum daily temperature. Now, the marking kit from NISA will have something a little bit simpler or more succinct. What I wanted to highlight here in terms of our learning outcomes is that there's a clear comparison. Latitude has a stronger correlation than height above sea level. And there's a variety of ways that you could do that, but we really want to compare, and that comparison is what's going to help us justify our decision. All right, and then question 31. This was a really lovely question. I enjoyed marking this one. It's a harder problem for the students to work through. On the positive side, almost all students knew to use the derivative to find the gradient of a tangent, and they started there. Most students also knew to use the point gradient formula from that to find the equation of the tangent. I think the other positive I found with this one, we're often saying show or working, but students really did demonstrate strong working, showing their strategies for solving the problem. There was plenty there for us to look around on the paper. They've tried something, they've tried something else, and they did a really good job of demonstrating that. So common errors for this one, students were a bit confused by the provision of the 2 points, a squared minus 1, and then 3 minus 8. So they assumed that 3 minus 8 was a point on the parabola and then attempted to find the gradient on the parabola at x equals 3. Some students who could follow the whole process through to find the equations of the tangents didn't consistently apply their algebraic techniques to find correct tangents. So for me, the learning outcomes, more practice is needed with these unscaffolded multi-step problems. I know my marking team had mixed responses to this style of question, but I really liked it. And from my impression of the marking, and I've marked thousands, there wasn't much distinction. Well, I didn't notice any distinction between questions like this that previously were scaffolded and this one where they just had to progress through. I think just as many accessed the lower marks as would normally do so. And then obviously the higher marks are for our higher end students. Students, I think, would be well advised to draw a diagram. So this error where we had the thinking that 3 minus 8 was on the parabola probably wouldn't be there if a diagram had been drawn up. Doesn't have to be accurate, just to get a picture of what it was that the question was talking about. All right, thank you very much.